Okay, let's get started. Welcome everyone, and thank you for joining us for this September edition of Ask Tom series on working with graphs. And today we have a very special session by my colleague Jain Sharma, who will talk about using Oracle label security when working with graphs. Our Ask Tom series is archived here, and we restarted this series in April this year. We have lots of sessions on introduction, some customer use cases, introduction to the query language, introduction to algorithms, and today we're focused on security. Some basic housekeeping items. If you have any questions throughout the session, please put them in the Q&A box. We will answer them, and maybe some of them we will answer live. So again, thank you very much for joining us here today. With that, I'll turn this over to Jain.
Opening just right in case there's, for example, an issue with my internet connection, etc. So thank you everybody for coming today. What I want to do is start with first telling you what the session is about, then followed by a brief introduction to the pieces that are being used in this demo. So it's going to be a short presentation followed by a demo. The focus is mainly on the demo. And what we are going to look at today is the use of row level security. That means secure access at the level of a row, possibly even at the level of a column, by using the advanced security options in Oracle. So what does that mean? So for a graph, that means we have, let's say, a single graph. The graph in this case is going to be bank accounts and money transfers between those accounts. We have a single graph. We have 3 different users, and we will have each of which has different level of access. So there's one user, so Jayant, who owns the data and has access to all of it. So if you connect as Jayant, for example, you would see that there are 1,000 accounts, and Jayant would see all the money transfers. The other user, Jim, has access also, but there are 10 accounts that are labeled as being highly sensitive. So the accounts are going to have 3 different classifications: highly sensitive, sensitive, or unclassified. So Jim can see only 990 of them. And the third user, Hans, has access only to the unclassified information. And if time permits, in the demo at the end, I will also show how to make it so that Hans cannot actually see certain information or certain properties or a row column combination, in this case, the amount of a transfer. But what you'll see in most of the demo all the way through is that Hans can only see unclassified and therefore cannot see those that are labeled as highly sensitive and sensitive. So what is all this based on? And that's what I'll very quickly go over. So I'll go over what is property graph support in the database, and also briefly introduce label security. That will be a very 30,000 foot overview, but enough to give you an idea of what is being used in this demo. And then I'll once again go through the demo steps, exactly what are the steps that are being followed, what is using which technology. So what's using label security and what is using property graph. And then Q&A, as Melly said, you can ask in the chat, and we'll also have some dedicated time at the end. So first, let's start with what is the property graph support in the database? So the first thing is, well, what are graphs? The graphs are a different way to model your data. And where are they used? They're used in, for example, financial industry to find anomalies or things like circular transactions. So you start with account A, you transfer money through 4 or 5 different intermediate accounts, and then it ends up back in account A. That's an example of a pattern that you search for when you're investigating suspicious transactions. It's used in manufacturing, for example, to find hidden dependencies. What happens if I change a part? Which assembly lines are affected? Which products are affected? So this capability is built in. It's integral to an Oracle database. And the benefit over there is the following: is you get all of the capabilities of the database, the scalability, the security, as we're going to demonstrate today. And in addition, we add features that make it easier for you to interact with these graphs. So a query language, which is very similar to SQL, but lets you express those patterns. For example, a circular transaction. How do you express that pattern in a graph query? And then analytics that are specific to graphs. For example, PageRank, that is find the important nodes, or community detection, find clusters, find communities, find groups of entities that are having interaction with each other and not with others. And finally, actually visualize those results. So let's start with the basics. What's a graph? It's a collection of nodes and edges that are connections between those nodes, and the edges represent relationships. For example, Melly transferred some money to Jean, or Melly purchased something from John. Each of these entities, the nodes and the edges themselves, can have properties: an address, an account number, a date that a transfer happened, or the amount of the transfer. So how do you create this graph? So let's say we have database tables, which are accounts and transactions. We have a data definition language, so that's part of the PGQL, a DDL syntax in which you describe which tables become nodes or vertices, what are the properties of those vertices, which tables have information on the edges, that is, they define what is the origin, what is the destination. So what's the from node, what's the to node, and then what are the properties of that edge, in this case, the amount. And then you can indicate what those vertices and labels are. So in this case, we assign a label which says these are accounts. We assign a label that says that this edge represents a money transfer. Once you do that, you can visualize it. This is an example of what the visualization of the previous graph would be. So how do you do that? Well, you issue, in the visualization application, you issue queries and you visualize the results of those queries. So let's look briefly at what is that query language. So this is a graph which shows accounts and transfers, money transfers between those accounts. So let's say that, and I was talking about circular transactions. Here's an example. Transferred money from one account to another and then back to the original account. And that would be an example of how you represent that. So it is the match clause, that's where it differs slightly from pure SQL, but the match clause is what is specifying the pattern. What is the origin? What is the edge? You may filter it based on a property of a vertex or an edge, and we'll see some of those examples later. Let's look at some slightly more complicated queries. So you want to find, is there any path that goes from account 528 to 569? So you say, is there an edge between 528 and 326, followed by, is there an edge between these two? And you can then specify which property helps identify what this vertex is. So you can then extend that and start to do much more complicated patterns. You can find, are there cycles, start and end at the same place? Are they connected? So this is an example, let's say in a manufacturing graph, you want to say, what's the effect of changing this part? How many places is it used in? How many assemblies? How often? So you can then compute, if I need to reorder this part, how many instances do I need? You can find the shortest, the fastest, the cheapest path, for example. And finally, more importantly, you can see much more complicated patterns. So here, for example, this is from one of our customers. They're seeing a pattern which is known as, in their jargon, is known as placement and integration. So money has originated from an account. Parts of it are placed in lots of different accounts and then placed back in some destinations. So that's the placement, that's the integration. And this is an example of a suspicious transaction. They want to see whether this was being done to circumvent some kind of regulation. For example, a limit on placing in an online betting, for example. So that was the piece about graphs. The next is, what we're going to do is apply label security, so Oracle label security on these graphs. So the first thing about the security is, what is it? It's essentially rules that say who can access what data when. So you can, let's say you have an HR database, an employee can view public information. So they can view the employee name, manager, let's say some contact information. They cannot view information about salary or a personal identifier. However, you can view your own information in order to update it or correct some errors. Or a manager can see information about her employees. So you can do this either through an application logic, and everything is built into the application logic. Multiple applications, each can have their own logic. And then what you have then is all of this security information, who can access, who can't access, under what conditions, is fragmented. So there are two issues with that. One is it may not be consistent across all the applications. The second is, if you have to do an audit and to see who accessed what, when, it's a much more complicated process. So one option, and that is what Oracle Label Security does, is you put the security where the data resides. So that gives you a central and consistent security. But more importantly, it also gives you an audit capability. So you can exactly track who accessed what, where, when, and how. So that is what we will be using here. And so there are a few things to know that are important. The first thing is, how does this work? So you assign, I talked about row level security. It's also known as label security. So you assign a label to each row or each data element. And then you give users privileges or access based on those labels. So Jayant can access highly sensitive and sensitive. Hans can only access unclassified. Jim can access sensitive and unclassified. So you label the data, you say what the users can access, and that is all that I'm using in this demo. But in terms of what Oracle Label Security provides, is you can actually have different, a hierarchy of these. So you can have labels that are applied. These labels can be grouped or themselves assigned to a compartment. So for example, a department within an organization, HR can see something, product development can see something else, marketing can see something else, again, based on these labels. These departments themselves can be restricted by, for example, a geography. So HR department in Asia can only see information about employees in Asia. We will just be using this part in the demo here, but all of this is applicable to graphs. So quick example, you have, let's say this a project, and there are labels. This user has been said that you can see highly sensitive and A, B, and D compartment. So when the user tries to access the data, so let's go back to this, you won't be able to see things that are from compartment C or compartment E. Okay, so that in a nutshell is what graphs are, how label security is applied. We will be applying the label security to the nodes and to the edges. So the demo scenario here is that we have a graph which has bank accounts and money transfers between those accounts. These accounts, and hence the corresponding transfers, have a data classification, which is highly sensitive, sensitive, and unclassified. And there are 3 users. Jayant is the owner and hence can see all of the data. Hans can only see unclassified data, so that's the accounts or the transfers. And Jim can see sensitive and unclassified data. So the steps involved, in terms of the property graph, we already have what I'm going to show here is I already have the graph created, and I'm going to walk through the rest of the steps. The graph is created and owned by the user Jayant, and hence access was granted to Jim and Hans. And what does that mean? That's the same as in SQL, you say grant select on this table to user Jim and user Hans. That's essentially what is done, except I did it here through a role. That's not important. But the steps, most of the steps are setting up the label security part. So that is, first is create a policy. And the policy simply says that I am creating a label security policy on these tables, and the label column name, that is, which is the column which will actually have the row label, that is what you assign. Then you decide what are the classification levels and what should be those labels. So while the levels may have descriptive names such as highly sensitive, sensitive, unclassified, the label itself may just say HS, S, or U. Then you define what users can see. So who can access all the data, who can access only sensitive and unclassified, etc. Then apply it on the tables, in this case, the graph. Then set the actual values and then enforce the policy. And the other thing, if time permits, what I'll show is that once that policy is enforced, it also applies to insert, update, and delete. So as you insert data or delete or update data, you still have that same classification. If I insert data as Jayant, which is labeled as highly sensitive, then Hans won't be able to see it. So let us go to the demo itself. And end here. Okay. So the first step is I have to connect to my system. One sec, let me get rid of this ribbon. All right, Melly, you can see my screen relatively clearly?
Yep, you can.
So I'm going to go there. I have to say, oh, what happens if I just do a tab? Oh, good. What I'm connecting to, actually connect, I want to connect this. So Jayant is the owner. Okay, so one other thing in this whole label security is there is one person who's the administrator, and that administrator is the one who sets up all of this. So I'm just to save myself time, rather than create a fourth user, I'm just doing everything as the user Janth. So we connect. The second step is undo things that may have been done. I've run through this once, so I want to undo what's already been done, which is a policy that was already applied and enforced. Okay, I like to see these things, so let me just do that. Grant access, I've done that. I'm going to skip that point. And the second one is actually create the policy. That's the demo effect. So what's going to happen here is it defines the policy. The policy is named Bank Oracle Label Security Policy. The column into which all the labels will go is Bank OLS column. It's going to be disabled initially. And this option hide says, don't let people see this column. If they do a describe table, they won't actually see that column. So the next thing is now to do all the other steps, which is create the labels, do the users, etc. So log back in again. That's Janth. And then do the next step, which is create the levels. And so the levels that we've created are highly sensitive, and unclassified. And the user, who's the administrator, will have this privilege, level-based access control DBA. The user who created and defined a policy will have this role, which is a DBA for that policy. So we've created the levels, create the labels. I'm just using HS, S, and U. And then these label tags, this is what will actually go in when we do some inserts. These are the values that will be used, numeric values. So we've done the levels, we've done the labels. Now we apply that to the tables. So a graph has vertices, so that's what these are, and edges, so that's what these are. So it says, I've applied this policy on these tables, and the policy applies on read, on insert, update, delete, and do not show the column. So if I say describe you won't see any column called Bank OLS COL. So we've applied the policy. Now we decide what the users can see and can't see. That says Hans can see things that are unclassified, and that's it. Janth can see things that are highly sensitive and below. When you insert something as Janth, it will be labeled as highly sensitive. When you insert something as Jim, it will be labeled as sensitive. So now you, having set those levels, you set those privileges. And this is saying the user Janth has full access, Jim can change a level up or down based on the max and min. So that's what these max and mins are, the levels. So Jim can change something from unclassified to sensitive, for example, and Hans can only change something from unclassified up to sensitive. Actually, no, that's not true. Hans can't change anything. So everything is a U up here. Okay, so the privileges have been set. Now let's go in and actually make the updates which assign those labels to the rows. So we'll make all of those updates, and then you'll see that there are 10 accounts that are highly sensitive, 10 that are sensitive, 980 that are unclassified. So correspondingly, there are 1,077 money transfers that fall into the highly sensitive category. So we've created the levels, the labels, decided all the user access, updated the rows. Now it's time to actually enforce that policy. So it's gone from disabled to enabled. Okay, so the policy is enabled. The last step is to actually apply it on the graph. So it's enabled on the graph. Now that we've done that, we can actually see that it's verify that it is in place. So let's do that. What we are going to do here is connect as the 3 different users and see that they have different levels of access. So Melly, is it okay if everything's showing at the bottom of the screen, or should I do a clear?
No, I think it's fine. It looks clear.
Okay. Actually, I think I have it all baked in here itself. Yeah, I do. Oh, so at this point, we're actually going to be doing something called PGQL queries. So running those match clauses and finding things, expressing the patterns between the edges and things like that. So how is that happening here? I'm still using SQL CL, which is the command line interface for doing SQL queries. So we will be using something which is a plugin, and the plugin lets you express PGQL inside the SQL CL prompt. So when I say PGQL auto on, the prompt will change, and at that point, I can issue queries against the graphs. So connect as the user, Janth, run some PGQL queries. So turn on the PGQL mode. So once that's done, I'm going to run the queries. The first one is, how many accounts can Janth see? Janth has access to everything, and therefore can see all 1,000 accounts and all 5,001 transfers. Let's do some query which says, which are the top 5 accounts into which, which have had the most number of incoming transfers? So we want the incoming transfers. So money being transferred in, that's what the arrow is indicating. So from this account into this account. So what is the destination account that we want? That is what we do. So we do a count based on that, and all we want is the top 5. So we limit it to 5. Okay, so that was what Jayant can see. Let's run these queries now as Jim. So we run these queries as the user is Jim. Jim can see only 990 of them. Can't see the 1077 transfers which were labeled as sensitive. And therefore, the list of the top accounts is different. So for example, above there was 934 and 387 and 135. Those don't show up here. Did I? There we go. The last one, Hans, 980 accounts, 4385 transfers. Again, a difference between the accounts that have the most number of transfers in there. So we've seen how to do this and verify the fact that it's all being applied in the database. We run PGQL queries directly against the graph in the database. So the other thing that is part of the property graph support is an in-memory analytics engine, right? So you can load the graph from the database into memory and then run analytics there. So what happens in that? Let's try and run that and see. Let me see if I'm still connected. I am. Ooh, those colors are bad. So I'm going to do this whole shell. I just want to have things up and ready so that I can copy and paste as we go. So the first thing to do is to start. So we're going to load the graph into the in-memory engine. We're going to connect to that in-memory engine using a shell that's made available. So that's the J shell. Actually, Melly, you want to take a minute or two to describe that while I furiously type away over here?
Yeah.
Okay.
So we have multiple clients that you can connect to the in-memory server that Jayant is talking about. So first he showed how we can run graph queries in the database. Now we can run graph queries on the in-memory graph server. And there are multiple clients we can use to connect to the server. JShell is one client that we support. So you can write Java snippet code, easy for, nice to do for demos like Jayant is using here and POCs and so on. We also have Zeppelin interpreters, and you can use Zeppelin and run PGQL queries, or of course you can have a Java application.
Okay, so I've already started up the server. The server is already running. So I started up the shell, and let's do all the things. So the first step is, well, actually, no, that's not the first step. I want to load some utilities to make life easier. And these utilities actually are from a colleague of mine, Albert Gottfried. And this portion that I'm using here, the utilities and this thing, all of this code is available on his GitHub. And we'll have a blog post soon describing exactly how to use it and why it's useful. In fact, you'll hopefully see why it's useful as I use it. I do not want to broadcast that. So I will do that. Okay, now the steps come. Connect to the server, establish a session, instantiate the analytic engine, which will run algorithms. And in fact, in this case, it runs both the algorithms and the queries. And then do what we need to do in order to do what we need to do, we actually have to load the graph. So we have to connect to the database. So we have to tell the server where to pick up the password. Obviously, this is not the real password. But let's first start the graph as the user Janth. We load that. Now the server is going to go connect to the database, load the graph, and it loads everything. We've seen that. Let's just validate it. Run a few queries. Let me see how we are doing for time. I think I want to do the visualization piece. Okay. So sees all the accounts, all the edges. The top 5 again had 387, 934, 135. Let's do that and see if it works. The same for Jim. Connect as Jim. Run these same sort of queries. 990 vertices, 4642 edges, 934, 135, and 387 don't show up as the top accounts. These other ones show up instead. And the last is the last sanity check. Do this as Hans. Hans sees 980, 4385. We can run these queries to verify that yet again. And Hans again sees a different set of accounts, right? Okay, so we've done that piece too. Now I said if there's time, we will look at the inserts. So let's do that, which is right here.
And now you're back in the SQL client, right? You're inserting.
Back at the SQL client, I'm going to do inserts and deletes. So let's walk through that. I insert 3 accounts, right? Account with IDs 1004, 5, and 6 as the user Janth. And when Janth does an insert, the default right level was sensitive. So this will be labeled as being sensitive, which means Hans can't see it. So insert some transfers between 1004 and 1005 and 1004 and 1006. Okay, so we've done that insert. Then come in as Jim, insert 3 more. But when Jim does the insert, they're all going to be unclassified. Therefore, Hans can see it. So let's go look at that. Hans can see 3 accounts that Jim inserted. Okay, and then just to clean up after myself, come in and delete. And the other thing I wanted to explain here is, since the edges are dependent on the vertices, when you delete the vertices, the edges also get deleted. And that's why you see this number here. And I think that's it. And we will stop here, take any questions. I might go back in and publish the graph, since we seem to have 20 minutes, and see whether visualization works, but no guarantees on that. But
let me ask a couple of questions while you do, just before you do that.
Okay.
So what was interesting to, I guess I just want to make sure I understood this correctly. So what was interesting was you set up all the security context and all of that using SQL, right, in the SQL prompt. And then you very seamlessly moved into querying the graph with PGQL.
Correct.
which was then able to see use all the security settings that you had set in SQL.
Yes.
So what was interesting was that you kind of seamlessly moved from SQL to PGQL, and then when you're doing inserts, you're back in SQL.
Exactly. And the fact that those settings still apply. So while I'm doing the inserts, those labels get applied automatically.
Right.
Get enforced automatically.
All right. So what's interesting, so that's why when we work with graphs in PGQL, you're still able to leverage all the security features that the database has. Right. It's just that part is seamless. Right. And that was very interesting. And this applies to both, even if you're running the graph queries in the database or if you're running the graph queries in the in-memory server. In both cases, you're leveraging the database security piece.
Exactly.
Right.
Okay, so that was as Hans. All right, you can take some more questions in the meantime while I do this.
Right. So another question here on whether the graph feature, how is it available for somebody to try? And the answer is that it is a feature of Oracle database. There is no separate licensing required. If you have a database license to either Enterprise Edition or Standard Edition or Express, you can use this feature. On the cloud, it's also available on the Autonomous Cloud free tier. So if you have a cloud account, you can try some of these examples. And of course, with Autonomous Database and the Graph Database cloud service. And of course, Exadata. So it's available with a variety of database editions. So, and no additional licensing required. There's another question on, is the updated data also updated in memory? And that's a good question. So in this case, what Jayant was showing was, and Jayant can correct me if I'm wrong, but Jayant was showing was that he's updating the data that's persisted. So the graph is persisted and he was updating the persisted copy of the graph.
Yeah.
You can use PGQL to also update your graph in memory. And that will be only used for that graph's context. When you're working with a graph in memory, it will be persisted there. It will be used there, the updated data. But it will not be persisted back into the database. If you want to persist changes, then you should make your updates in the database, perhaps using SQL.
Yeah.
And the question here, which we get a lot, is about getting started. How can I get started? We do have some lots of getting started labs, and we can, I don't know whether we have a pointer to that, but you can look for that. I think we have posted some in the blog that you can get started in a cloud instance very quickly. So, okay, so I think that's it for the questions now, Jan.
Okay. Well, anyway, we have the graphs loaded. You can do basic queries to visualize the graph. So in this case, I just want to see most of it. Actually, let me change one thing. See more of the graph in one go.
And you're running this in a browser, correct?
Running this in a browser.
Yeah.
I just want to see what these things are called. They're called account, okay, and what other properties of an edge. It's called transfer, and it has an amount and a source and a destination. And this is ID. Okay. So we can do things such as, well, we can run any of the other PGQL queries out there. The ones which were for looking, let's look for something which starts, this is as Janth.
So while you're typing, I'll just talk a little bit more about this. So yeah, what Jayant is doing now is he's running a PGQL query, and that's what the graph visualization tool allows you to do. Run a PGQL query in this browser UI and then visualize the results in the graph.
Right.
The browser, sorry.
So let's look at something which goes through three, or actually why not 4 hops? Do one more. And then it ends up back. And okay, I didn't ask for the edges. That's why we got this kind of a look. Okay. This is why I was hesitating to do all of this.
Mm-hmm.
This is the time for more questions.
Right. When anything that is enclosed in a parenthesis is a vertex, that's the syntax of the match class. Anything that is enclosed in square brackets is an edge. So now Jayant is also including the edges so that now we can see the edges. There we go.
And since this was a circular transaction, it might be better to view this as a hierarchy. So let's actually see the start, all the nodes, and let us visualize it as in a hierarchical fashion, so that you can see it starts from here, goes someplace, etc. And you can keep changing the views. You can add other things that help you identify prominent nodes based on, let's say, the amount that the transfer was, for example. And so I ran this query on this account, right, which has access to everything. If I take this same query, so let me keep it, run it on the graph that Hans has access to, you should get no result. Let me see what Hans is able to see. We're assuming all these numbers make sense, but they may not. So Hans is able to see 389. All right. Okay. So hopefully this was useful.
Yeah, I think so. I think it is very useful because the questions we often get is that, okay, graphs are interesting and very nice, but how can we bring in some of the database features that we need to do for enterprise grade applications, such as label security and so on. So I'm glad that we're able to cover that in this session. And there's another question on RDF graphs, which I answered. What would you, so currently this visualization tool is for property graphs, including RDF graphs is on the roadmap. So with that, we can wrap up this session. Thank you very much, Jayant, for putting all of this together. This session has been recorded and will be archived on the AskTom website. And we'll plan to make some of these examples available either through a blog or GitHub. So thank you very much for attending, and see you next time.